Hey everyone, welcome back to Talk Tensors. Today we're diving headfirst into a paper that's making waves in the AI world.
Making waves is right. It's called Go with the Flow, Motion Controllable Video Diffusion Models, using real-time warped noise.
Catchy title, right?
Yeah.
But what does it all mean?
Well, in a nutshell, it's about giving us, the users, more control over how AI generates movement in videos.
Like becoming a movie director, but for AI.
Exactly.
So we're not just talking about creating videos from text prompts or images anymore. This is about controlling how things move within those videos.
You got it. And that's actually been a pretty big challenge for video diffusion models, how to get that fine-grained control over motion.
Yeah, I can imagine. Current models are amazing at creating the visuals, but getting them to make a character walk across the screen in a specific way, for example, that's a whole other ballgame.
It is. It is. And there have been attempts to tackle this motion control problem before, but they often involve making complex changes to the model itself, or the video quality would take a hit.
So what makes this go-with-the-flow approach different?
They've come up with this really clever idea of using structured noise.
Structured noise, what does that even mean?
So typically, diffusion models are fed random noise as input, right? It's like the starting point for the generation process.
Right, I've heard you talk about that before.
Well, in this case, they're using something called optical flow to create what they call warped noise.
Okay, hold on. Back up for a second. Optical flow.
Oh, right. Sorry, I sometimes forget not everyone eats and breathes this stuff like we do.
No worries. That's why we have you here.
Optical flow is basically a way to map how pixels move between frames in a video.
Oh, I see. So it's like a blueprint of the motion.
Exactly.
Mm.
So instead of just throwing random static at the model, they're giving it this warped noise, which is structured based on the desired motion.
So the AI is kind of learning from a motion cheat sheet in a way.
You could say that. By training the model on this warp noise, it starts to learn to associate specific motion patterns with specific noise patterns.
It's like teaching the AI a whole new language, the language of movement, but a language made of visual code.
I like that, a language of visual code. That's a great way to put it.
So is this warped noise approach easier to integrate into existing models?
That's one of the best parts. You don't have to redesign the entire model's architecture. It's all about fine-tuning.
Which means it could be applied to a bunch of different video diffusion models.
Exactly. Super adaptable.
That's really smart. Okay, so what kinds of motion control can we actually achieve with this? Can you give us some examples?
Well, the paper highlights three main types. First up, local object motion.
Local object motion.
So think about being able to drag an object around in a video, and the AI would realistically animate its movement based on where you drag it.
Wow. That would be so cool for animating characters in a video game or even adding special effects to a movie.
Totally. So what else?
Global camera movement.
Okay, I'm intrigued. What's that all about? Imagine you're a filmmaker, right? You have this amazing shot from your favorite movie with these sweeping camera moves.
And you could use that camera movement to create a completely new shot with different characters or a different setting.
Exactly. Using the optical flow from that original shot, you could control the camera in your AI-generated video.
That would be incredible.
Yeah.
Okay, and what was that third type of motion control you mentioned?
Motion transfer.
Motion transfer.
So this one lets you take the motion from one video and apply it to a completely different scene. Imagine taking the graceful movements of a dancer.
And putting those movements onto, a robot.
Precisely. Or, any other object or character. The possibilities are pretty mind-blowing.
This all sounds incredibly promising. But I'm curious, how do they make sure that this warped noise still plays by the rules, so to speak? Doesn't it have to follow certain properties for the model to work?
That's a great question. And it brings us to the concept of Gaussianity.
Gaussianity.
Don't let the fancy word scare you. Remember, we're dealing with noise here, and for this whole thing to work, that warp noise needs to maintain a specific statistical property, a Gaussian distribution. Think of it like, making sure all the ingredients in a cake are properly balanced.
So if the noise isn't mixed right, the whole system could fall apart.
You got it. And what's really clever is that their algorithm manages to preserve this Gaussianity while also warping the noise according to the motion we want.
So they're walking a tightrope, but they're managing to stay balanced. That's pretty impressive.
It is. And speaking of control, the paper also mentions something called noise degradation.
Noise degradation. Okay, another one for the glossary. What's that all about?
Think of it like a control knob for how closely the AI-generated video sticks to the input motion. Let's say you want to create a video of a cat jumping.
Okay, I love cats. I'm following you.
High noise degradation would give the AI more creative freedom. Maybe the cat adds a little twist or a tail flick as it jumps.
It can improvise a bit?
Exactly. But lower degradation means the output video will be a more faithful recreation of that original jumping motion.
So it's about finding that balance between letting the AI do its thing
Yeah,
and maintaining control over the final product.
you got it. It's like being a director, but giving your actors some room to improvise.
I like that analogy. Makes sense. Now, you mentioned something earlier that I wanted to circle back to, this idea that go with the flow could work with image diffusion models too, even models that haven't been specifically trained for video.
Yes, that's one of the things that really got me excited about this research.
So you could take a still image and using this motion-guided noise, you could bring it to life.
Exactly. They've shown some really cool examples of using this technique for things like video super resolution, taking a low resolution video and upscaling it while maintaining smooth motion, and even relighting, changing the lighting in a video after it's been created.
And all of that without having to train the model specifically for video tasks.
Exactly.
That's pretty remarkable. It really shows how powerful and versatile this approach is.
It does. It opens up a whole world of possibilities. It really does make you wonder what else we can achieve with this kind of motion-guided noise.
It's like we're just scratching the surface of what's possible.
Absolutely. And to really appreciate how groundbreaking Go with the Flow is, I think it's helpful to take a step back and look at the history of what led up to this breakthrough.
Okay, I'm game. So what's the backstory here? How do we get from those early kind of janky AI-generated videos to the kind of sophisticated motion control we're talking about today?
Well, it's been an amazing journey full of twists and turns and unexpected breakthroughs, but I think it all really starts with the rise of deep learning.
Ah, yes, deep learning. That's when things really started to take off in the AI world.
It changed the game completely. Suddenly, we had these incredibly powerful tools for training models on massive amounts of data.
And the results were mind-blowing. Image recognition, natural language processing, it felt like every field was being revolutionized.
It was an exciting time, and a pivotal moment in this journey was the rise of generative adversarial networks, or GANs, as they're more commonly known.
GANs. Oh, yeah. I remember when those hit the scene. The idea of having these two neural networks, a generator and a discriminator, duking it out to create realistic images, it was just incredible.
It was, wasn't it?
Well,
You have this generator trying to create fake images that could fool the discriminator, and the discriminator trying to tell the real from the fake. This constant competition pushes both networks to improve, resulting in increasingly realistic outputs.
and GANs were responsible for some pretty impressive results, right? I remember seeing those AI-generated faces that were virtually indistinguishable from real photographs.
They were a powerful demonstration of the potential of generative models. But even with all their success, GANs also had their quirks.
Works.
They could be pretty tricky to train, and sometimes they would get stuck in a rut, producing only a limited variety of outputs. This is something called mode collapse.
Ah, so it's like the generator gets stuck in a creative rut, only able to churn out variations on the same theme.
Exactly, and that's where diffusion models came in. They offered a more stable and controllable approach to image generation.
So they were like the next evolution, solving some of the problems that GANs had.
Exactly. Diffusion models work by, well, it's kind of like this. Imagine you take a beautiful painting, and then you gradually smudge it with more and more noise until it's completely unrecognizable.
Okay, I'm picturing it. A masterpiece turned into a blurry mess.
Then you train the model to reverse that process, to take that blurry mess and gradually remove the noise until you get back to the original painting.
So it's learning to create by first understanding how to destroy.
That's a great way to put it. And because diffusion models are probabilistic, they can generate a wider range of outputs from the same input.
And that means they're less likely to fall into that creative rut we were talking about.
Exactly. Much less prone to mode collapse than GANs.
So diffusion models kind of opened up this whole new toolbox for controlling the generative process.
They did. They gave us more knobs to turn, more levers to pull, and I think Go with the Flow really builds on that foundation.
By adding that crucial element of motion control.
Exactly. And it's like they've brought together years of research on generative models, culminating in this really powerful and versatile technique.
It really does feel like we're at a turning point in AI, doesn't it? Where things are starting to click into place.
Absolutely. And Go with the Flow is a prime example of that. It's taking the best of what we've learned from GANs, diffusion models, and optical flow, and combining them in a way that unlocks a whole new level of control and creativity.
It's pretty amazing when you think about it. Just a few years ago, AI-generated videos were often, well, a little rough around the edges.
To put it mildly, objects would pop in and out of existence, movements would be jerky and unnatural. It was clear that we hadn't quite figured out how to make things move smoothly and realistically.
Yeah, it's like those old stop-motion animation films where you could see the seams between the frames.
Exactly. And a big part of the challenge was achieving temporal consistency, making sure that the transitions between frames were smooth and seamless, so it didn't look like a slideshow of unrelated images.
Right, so how do we get from those early, somewhat janky AI videos to the kind of sophisticated motion control we see in Go with the Flow?
Well, it's been a journey of incremental improvements and breakthroughs. Researchers have been chipping away at this problem for years, trying different approaches, refining techniques.
So it's like a relay race, with each team building on the progress of the one before it.
That's a great way to think about it, and I think Go with the Flow represents a significant leap forward in that relay race.
It's taking the baton and running with it.
Exactly. Now, I know we talked about Jan and diffusion models earlier, but there's another key player in this story that I think is worth mentioning. Optical flow.
Oh yeah, we kind of glossed over that before. Can you remind us what that is again?
Sure, optical flow is basically a way to calculate the motion of objects or pixels between frames in a video sequence. It's like creating a map of how things are moving.
So it's like a behind-the-scenes look at the motion that's happening.
Exactly. And this information is incredibly valuable for a variety of computer vision tasks, including motion tracking, object recognition, and video stabilization.
And now, with Go with the Flow, it's playing a crucial role in controlling AI-generated motion.
Exactly. By using optical flow to create that warped noise we talked about earlier, they're able to guide the diffusion model's generation process in a way that produces specific, controlled movements.
It's like they're giving the AI a roadmap for how to move.
That's a great analogy. It's like saying, okay, AI, I want you to create a video of a person walking across the room, but I want them to walk in this specific way, following this path with these particular movements. And the optical flow provides the guidance to make that happen.
That's really cool. So it seems like optical flow has been a crucial piece of the puzzle all along.
It has, and I think its role in Go with the Flow really highlights how important it is to have a deep understanding of the underlying principles of computer vision if we want to create truly sophisticated AI systems.
It's like you need to know the rules of the game before you can start bending them, right?
Exactly. You need a solid foundation in the fundamentals before you can start pushing the boundaries and exploring new frontiers. And speaking of new frontiers, I'm really excited to share some novel notions with you, some potential research directions that this paper has sparked in my mind.
Okay, I'm all ears.
Yeah.
Let's hear those outlandish but plausible ideas.
All right, so let's indulge in a little speculation, shall we? Just remember, this is all for fun, and who knows, maybe some of these ideas will inspire future research. What if we could use Go with the Flow to create personalized motion avatars?
Personalized motion avatars. Okay, now you've really piqued my curiosity. What do you mean by that?
Imagine being able to capture your own unique movement style, the way you walk, run, gesture, everything that makes your movements distinctively you, and then using that data to create an AI-powered avatar that moves exactly like you.
Wow, so it's like having a digital twin that can move and interact in virtual worlds.
Exactly. It would be like having a digital puppet that you could control with your own movements. And think about the applications. You could use it in video games, virtual reality experiences, even telepresence applications.
That's a wild idea. It would be like stepping into a video game or a virtual world and actually being yourself with your own unique movements. It would add a whole new level of immersion and realism.
It would. And it could also be incredibly useful for things like physical therapy or rehabilitation. Imagine being able to create a virtual environment where patients could practice movements and exercises with their personalized avatars, getting real-time feedback and guidance.
That's a really cool application. It would be like having a virtual physical therapist right there with you, guiding you through every step.
Exactly. And there's another potential application that I'm particularly excited about. What if we could use Go with the Flow to automate the process of animation?
Automate animation. So you're talking about creating cartoons and animated films without animators.
Not necessarily replacing animators altogether, but definitely augmenting their abilities. Imagine a world where animators could simply sketch out rough movements or poses for their characters and then Go with the Flow could fill in the gaps, generating smooth, realistic motion sequences that bring those sketches to life.
That would be a game changer for the animation industry. It would free up animators to focus on the creative aspects of their work, while AI handles the more technical and time-consuming tasks.
Exactly. And it could also open up new avenues for creativity. Imagine being able to quickly experiment with different animation styles or explore entirely new forms of movement that would be impossible to create by hand.
It's like having an AI assistant that can help you push the boundaries of what's possible in animation.
Precisely. And there's one more novel notion I want to throw out there, something that's a bit more speculative, but I think has the potential to be truly transformative. What if we combined go with the flow with evolutionary algorithms?
Evolutionary algorithms. Okay, now you've really lost me. What are those?
Evolutionary algorithms are a type of optimization algorithm that's inspired by the process of natural selection. They work by creating a population of candidate solutions and then iteratively selecting the fittest solutions, mutating and recombining them to create new generations of solutions.
So it's like survival of the fittest, but for algorithms.
Exactly. And what if we applied this concept to go with the flow? Imagine creating a population of different motion control parameters and then using an evolutionary algorithm to select the parameters that produce the most aesthetically pleasing, realistic, or otherwise desirable motion sequences.
So we'd be essentially breeding AI that can generate incredible movements.
In a way, yes, we could explore vast and uncharted territories of motion, discovering new forms of expression that might never have been conceived by human choreographers or animators.
That's mind-blowing. It's like we're giving AI the power to evolve its own unique dance language.
Exactly. And who knows, maybe this could even lead to a deeper understanding of human movement and creativity. By studying the movements generated by these evolutionary algorithms, we might glean insights into the underlying principles that govern human motion and aesthetics.
This is incredible. I'm already imagining all the amazing possibilities that could come from combining these cutting-edge AI techniques.
Me too. And I think we're only just beginning to scratch the surface. Go with the flow is a powerful tool that could revolutionize not just the world of AI, but also feels like animation, entertainment, healthcare, and beyond.
It's a testament to the incredible ingenuity and creativity of the AI research community.
It is, and it's a reminder that we're living in a time of unprecedented technological advancement, where the boundaries of what's possible are constantly being pushed further and further.
And on that note, before we get too carried away with our futuristic visions, I think it's time to bring this part of our deep dive to a close.
Sounds good to me. But don't worry, we'll be back soon with even more insights and discussions on the latest and greatest in AI research.
And who knows, maybe by then we'll have even more mind-blowing novel notions to share with you.
I'm sure we will. The world of AI is constantly evolving, and there's always something new and exciting just around the corner. It's been a blast, hasn't it? Exploring this paper with you.
It really has. Go with the flow is just such a cool concept. And the implications, it's like,
Yeah.
where does it stop?
Right. There's so much potential there.
Okay, so before we wrap things up completely, there was this one thing in the paper, I don't know, it just really stuck with me.
Oh, I'm curious. What was it?
Remember how they were talking about using Go with the Flow to fly through a 3D scene, with a virtual camera?
Yeah, I remember that. They created some really impressive demos.
Well, here's the thing that blew my mind. They didn't actually use a 3D model to create that scene.
Wait, really? How'd they do that?
Okay, so they started with a single image, a 2D image.
A single image,
Yeah.
and they turned that into a 3D fly-through.
Yep. They used this technique called depth warping to estimate the depth of different objects in the image. It's like they gave the image a third dimension.
So they essentially generated 3D information from a 2D source. That's crazy.
Right. And then they used that depth information to create a series of frames that simulated camera movement, as if the camera was moving through a 3D space.
Wow, that's wild. So they basically created a 3D world out of a single flat image.
Exactly. And then they used that warped image sequence to generate the optical flow needed for Go with the Flow. So, they fed that motion information into the model.
That's incredible. It really shows how powerful this technique is. They're not just manipulating existing 3D data, they're creating it from scratch.
It's like magic almost, taking a flat image and turning it into this immersive 3D experience.
It makes you wonder, what else is hidden within those static images that we just haven't unlocked yet?
Right. Maybe there's a whole universe of unseen dimensions waiting to be explored.
I love that thought. It's like we're just beginning to understand the true potential of these AI models.
Well, on that note, I think we should probably wrap things up here. This has been an incredible deep dive into the world of Go with the Flow.
It really has. A fascinating paper, and I'm so excited to see where this research leads in the future.
Me too. I have a feeling we'll be talking about this for years to come.
I'm sure we will.
And to all our listeners out there, thanks for joining us on this journey into the cutting edge of AI research. Don't forget to check out the show notes for a link to the full paper if you want to delve deeper into the technical details.
And as always, keep those minds curious and those algorithms humming. Until next time.
See ya.